Hello, my friends. Welcome to my channel. My name is sinjandebnath, and I am a PhD student in the Department of Civil Engineering of IIT Kharagpur. In this lecture series, I am going to teach soil mechanics, and I believe at the end of this series, you will have a deep understanding of this subject. These are the two books which I recommend for this course. The first one is The Soil Mechanics and Foundations by B.C. Punmia, Ashok Kumar Jain, and Arun Kumar Jain. The second one is The Basic and Applied Soil Mechanics by Gopal Ranjan and A.S.R. Rao. So, soil mechanics. Well, it is a branch of civil engineering that basically deals with the mechanical behavior of soils. So, soils. All the soils are made up of three components. First one is air, second one is water, third one is solids. These solids could be either organic material, inorganic, or both. Okay. Because of these three constituents, soils are also termed as three-phase systems. Okay. Three-phase systems. So these two components are present inside the voids, air and water. So what are voids? We all know soils are particulate in nature. That means they are made up of small particles. So suppose these are soil particles. We can see there are voids in between them. In these voids or empty spaces, there could be either air or water or both. Okay. Now suppose you have a handful of soil of volume V. So the total volume of soil that you have, we can represent it by V. Total volume of soil V. Suppose this rectangle represents the total volume of soil that you have. A fraction of the total volume is occupied by the solid materials, which we can represent by Vs. Vs represents the fraction of the soil solids. Okay, the total volume of soil solids. And the rest is the volume of voids. The rest are all voids, empty spaces. Now, in these void spaces, there could be either air or water or both. Now, if the voids are completely filled up with water, that means the volume of void is equal to the volume of water. In that case, we can say the soil is completely saturated. If there is no water, only air inside the void, there is no water, only air. In that case, we can say the soil is completely dry. And if there is both air and water inside the void, that suppose this fraction is occupied by the water and the rest is occupied by the air. In that case, we can say the soil is partially saturated. Okay. Now there are some simple definitions which we must know. Oh, before that, I forgot. So from this diagram, we can say the total volume of soil is equal to the volume of soil solids plus volume of voids, and the volume of voids is also equal to the volume of air voids plus volume of voids occupied by the water. Okay, the volume of water and the volume of air. And These diagrams are known as phase diagrams. So now let's come to the some simple definitions that we must know. First one is the water content. It is generally represented by small w. It is the ratio of the weight of the water present inside the soil to the weight of the soil solid or the dry soil. Okay. It can be expressed in terms of percentage. Second one is the void ratio. It is generally represented by small e. It is the ratio of the volume of voids to the volume of soil solids. Third one is the porosity. It is generally represented by small n. It is the ratio of the total volume of voids present in the soil to the total volume of soil. All these ratios can be represented in terms of percentage also. Number 4. Degree of saturation. It is generally represented by capital S, which is equal to the total volume of water present inside the voids to the total volume of voids. It can also be represented in terms of percentage. So now if the soil is completely dry, that means if there is no water present inside the soil, in that case we can say the saturation is 0. And if the soil is completely saturated, that means all the voids are filled up with water. In that case, total volume of the voids is equal to the volume of water. So in that case, saturation is 1 or 100%. Okay. Number 5. Air content. It is generally represented by small ac, which is equal to the volume of air present inside the soil to the total volume of voids. It can also be expressed in terms of percentage. Now, as we have seen earlier, Vv equal to Vw plus Va. So we can write it like this: Vv minus Vw by Vv. So we can say that this one Vw minus Vv, this one is the degree of saturation. So we can write it like this, 1 minus A. So AC equal to 1 minus A S. Number 6. Percentage air voids. It is generally represented by small na, which is equal to the volume of air to the total volume of soil. Okay. Now, unit weights. Well, unit weight of a soil is defined as the weight per unit volume. Weight of the soil per unit volume of the soil. Okay. So there are several types of unit weights. The first one is the bulk unit weight. It is represented by gamma. It is the weight of the soil, total weight of the soil to its volume. total volume. So you can write it like this: weight of the soil means weight of the soil solid plus weight of the water plus weight of the air, which is 0, to the total volume of soil means the volume of soil solids plus volume of voids. Okay. Number 2, dry unit weight. It can be represented by gamma d. It is equal to the weight of the dry soil. That is the weight of the dry soil or weight of the soil solids, whatever you may say, divided by the total volume of soil. Number 3, saturated unit weight. It is represented by gamma sat, which is equal to the saturated unit weight of the soil divided by total volume of soil. Number 4, submerged unit weight. It can be represented as gamma sub or gamma dash, which is equal to the submerged unit or submerged weight of the soil. Actually, submerged condition. What happens is that if the soil is submerged underwater or below the groundwater table, buoyant force will act on the soil solids, and this buoyant force is equal to the weight of the water displaced by the soil solids. So, it will reduce. So the net of the soil solid will get reduced. So that is the weight of this. So gamma sub is, so the W sub is the weight of the submerged soil divided by volume of total volume of soil. It can also be written like gamma dash can also be written as gamma sat minus gamma W. This gamma W is the unit weight of water, which is generally 9.81 kilonewton per meter cube. Number 5, unit weight of soil solids. Gamma S. Well, it is the ratio of weight of the solids or dry soil divided by volume of solids. Specific gravity. Well, specific gravity of soil solids is the ratio of the unit weight of solids to that of water. So you can write unit weight of solids to the unit weight of water. Okay. Now there are some very important relationships that we must know. The first one, we know porosity is equal to volume of voids to the total volume of soil. So we can write volume of voids, the total volume of soil we can write in like this: volume of voids plus volume of soil solids. Now, if we divide both the numerator and denominator by Vs, or the volume of soil solids, like this, okay. So this Vs Vv by Vs, what is this? This is E, void ratio. So we can write it like this. Okay. So porosity is equal to void ratio by 1 plus void ratio. This is a very important relationship. Second one, void ratio is equal to Vv by Vf. Okay, fine. We can write it like this: Vv by Vw into Vw by. We are multiplying both numerator and denominator with Vw, that is the volume of water. Okay. So now this Vw can be written as weight of the water divided by unit weight of water, and Vs can be written as weight of the soil solids by unit weight of soil solids, since because gamma W is equal to weight of the water divided by volume of water, and gamma S equal to weight of the soil solids or dry soil to the weight of the soil solids, the volume of soil solids. So you can write it like this. Okay. So this gamma S by gamma W, this is G, and this one weight of the water to the weight of the soil solids, it is water content, and this one volume of voids to the volume of water is the reciprocal of degree of saturation. So we can write E is equal to 1 by S into E is equal to 1 by S into water content into G. This is a very important relationship. ES equal to water content into G. Third one, we know bulk unit weight is equal to total weight of the soil by total volume of soil. We can write it like this: weight of the solid plus weight of the water plus weight of the air, which is equal to 0. Volume means volume of voids plus volume of soil solids. Now if we take Ws common from the numerator, we can write 1 plus W die Ws. We can write it like this. Now, if we take out Vs from the denominator, so it will be like Vv by Vs plus 1. Okay. Now this Vv by Vs, what is this? This is void ratio. And this one, weight of the water by weight of the dry soil or soil solid. This one is water content. So and this one, weight of the soil solid or dry soil to divided by weight of the soil solids. This one is gamma s, that is the unit weight of soil solid, which is equal to, so you can write it like this, gamma s 1 plus w divided by 1 plus e. Okay, we know gs equal to gamma s by gamma w. So gamma s will be equal to specific gravity into gamma w. So now if we put this over here, so it will be gs into gamma w 1 plus w, that is the water content, by 1 plus e. So now, so gs gamma w plus gs gamma w into water content by 1 plus e. Okay. Well, we know we have derived earlier es equal to wg. Okay, gs. We have derived this earlier, so you can say, if we, so you can say gs gamma w plus this one, we can write it like es gamma w by 1 plus e. Now if we take gamma w common, we can write gs plus es by 1 plus e. Now this is a very important relationship between the bulk unit weight and all the parameters. So bulk unit weight can be written as gs plus e into s by 1 plus e into gamma w. This one is a very important relationship. From this formula, from this bulk unit weight, you can derive all the unit weights, that is the dry unit weight, saturated unit weight, everything from this. Let me show you how. So gamma equal to g plus es gamma w by 1 plus e. Okay. Now if the soil is completely dry, that means s equal to 0. The soil is completely dry, that means gamma d. So that means if we put s equal to 0, so bulk unit weight will turn into dry unit weight, which is equal to g gamma w by 1 plus e. Now, if the soil is completely saturated, that means is equal to 1. So bulk unit weight will turn into gamma sat, which is equal to G plus is equal to 1. That means G plus E gamma W by 1 plus E. Very, very important. And gammas, and the other one is gamma sub or gamma dash, which is equal to gamma sat minus gamma W. So as we can see from the from this formula from this formula bulk unit weight, we can derive all the other unit weights: saturated unit weight, dry unit weight, submerged unit weight, everything. Okay. uh, okay, so another one is there, the last one, the last one. The bulk unit weight is equal to the weight of the soil to the weight of the volume of the total soil. You can write it like this: weight of the total soil is equal to weight of the soil solids plus weight of the water divided by volume of total volume of soil. So we can write it like this: if we take Ws common from the numerator, 1 plus Ww by Ws by V. This weight of the soil solid or weight of the dry soil divided by V, this is known as gamma D, or the weight of, or the unit weight of dry soil, and this weight of water to the weight of soil solid is the water content. So we can write gamma equal to, that is the bulk unit weight, is equal to gamma D into 1 plus W. This is a very, very important relationship. Okay. So okay, we have completed all the important relationships and definition. Okay, we'll continue in the next class. Thank you.